Our next lesson is solved by factoring. If an expression is an equation, but it is not equal to 0, like in example 1 below, rearrange it so that all the non-zero terms are on one side before you factor, meaning set it equal to 0 before you start. Step 2. Factor out the GCF of all the terms if possible. Step 3. Factor the remaining parts into 2 steps of parentheses if possible. Using any method, we've learned patterns, SuperX, grouping, all the methods we've learned last unit. Check each factor in parentheses to see if it factors again. If it can factor again, you redo step 3. Step 5. If the factored expression is an equation equal to 0, you can solve. And a couple little rules here. The zero product property says if A times B equals 0, then A is 0 or B is 0. For example, if 5 times blank is 0, we know that this blank has to be 0. It doesn't matter if this is 5, 50, or 7,000. So anything times 0 is 0. And set each factor equal to 0 and solve to find the value of the variable. The value of the variables you get are called your roots or your zeros, because they are the x value that makes a polynomial equal to 0. Unless these solutions turn out to be imaginary roots, which we'll not learn today, the roots or zeros are also called the x-intercepts when it's graphed. So if I had a graph like so, and it went something like this, then these would be my roots. Alright, let's get to example 1. Example 1 says to find all the roots. Remember the first step said if it's not equal to 0, set it equal to 0 first. To do so, I'm going to move this to the other side. And I get 0 equals 6x squared minus 19x minus 7. All I did was put it in standard form. That way it's easier to kind of view and solve next. I have 3 terms, and I taught that when there's 3 terms, we're going to do the super x. On top is 6 times 7, which is a negative 42. On bottom is your b, which is a negative 19. This is 6x and 6x. My two numbers that multiply to negative 42 and add to negative 29 would be a negative 21 and a positive 2. We can simplify. 6 divided by 3 would be 2x, and negative 21 by 3 would be negative 7. And then these 2 can go into both of these, so this would be a 3x and a 1. So I get 2x minus 7 and 3x plus 1. But now we have to set it equal to 0. And this is where the next step comes in. When you see this, now we're going to split these two up and solve them each. So this would say 2x minus 7 equals 0, and 3x plus 1 equals 0. Solve the one on the left, add 7, divide by 2, x equals 7 over 2, and the one on the right, subtract the 1, and divide by 3. X equals a negative 1/3. So I have 2 terms here. So a quick little recap is my degree, which means my highest exponent here, was a 2. And notice that I had a total of how many roots? 2. So those numbers match. Let's go to the next example. Example 2. Always look for GCF first, and we can notice that since they all have an x, at least one of them, my GCF is x. I notice that I have a 3 and a 2, a 15 and a 10. There is not one single number that can go into all of them. Therefore, my GCF is only going to be x. And I'm left with 3x cubed minus 2x squared minus 15x plus 10. Next step, look at everything on the inside of the parentheses and see what we can factor out there. I have 4 terms, which means I'm going to do factor by grouping, and that's going to be these two, then these two. Out of my red terms, I can take out an x squared. So this will come down, and if I take out an x squared, I am left with a 3x minus 2. Out of my blue terms, a negative 15x and a positive 10, I can take out a negative 5. And I'm left with 3x minus 2. Since I'm left with two things that are the same on the inside, the factor by grouping worked. So taking those terms out will leave me with x, parentheses, a 3x minus 2, because that's the pair that we saw on the inside. And everything that's left is x squared minus 5. Don't forget to set it equal to 0. First one is dx. This will just say x equals 0, therefore you're done. X equals 0, that's 1, 0. Number 2. 3x minus 2 equals 0. Add 2 to both sides. 3x equals 2, divided by 3. X equals 2/3. 0, number 2. And the last one. X squared minus 5 equals 0. Notice the x squared minus 5. It can't factor, but we can find two solutions because it's a degree of 2. So when you subtract 5, you're going to add 5, sorry. X squared equals 5. We can get rid of the square by doing the square root. However, when you do the square root, it leaves you with an answer of x equals a plus or minus radical 5. So my two answers are x equals positive radical 5 and x equals a negative radical 5. Once again, I have 1, 2, 3, 4 zeros, and I started with a degree of 4. When you start with an nth degree equation, you can have up to n roots. For example, if I have a 7th degree term or a polynomial, I'm going to have 7 roots. If you had a perfect squares in the problem, some would be identical, so you would see fewer roots. We call these double roots or roots with the multiplicity of 2. When we get to graphing, we'll see what that actually entails when it's a multiplicity of 2 or 3 or just a singles. We'll kind of notice a difference. Let's move on to the next part. In part 2, the polynomials are given in factored form, meaning they're already factored for you. Set each factor equal to 0 and solve to find the value of the variable. We will also turn these factored equations back into proper polynomials. Distribute to multiply. And by proper just means put them back in standard form. That's just review from last unit anyway, so that shouldn't be anything new here. So find the root, then rewrite the polynomial in standard form. Alright. We're going to split these up again. X minus 4 equals 0, and 2x plus 3 squared equals 0. On the left side, if we add 4, x equals 4. On the right side, notice that it's 2x plus 3 squared equals 0. That means we just have 2 of them. So technically, we only need to solve 1. And the reason is, if we wrote 2x plus 3 equals 0 twice, we would get the same answer both times. So it's just going to be a multiplicity of 2, and we'll see the answer right now. Subtract 3 divided by 2. And so I would have this twice, which means I'm just going to note here that it has a multiplicity of 2. Alright, so that's the first part. We found all the roots. Second part now is to write it in standard form. So I have x minus 4, 2x plus 3 squared equals 0. Now the square part is important for this one because it's going to say x minus 4 and 2x plus 3 times 2x plus 3 equals 0. You can multiply in any order you'd like. You can do x minus 4 and 2x plus 3 first, or you can do 2x plus 3 times 2x plus 3 first. It does not matter. So I'm going to do these two here, and it's going to be by distributing. I get x minus 4, and here I'll get 4x squared plus 6x plus 6x plus 9. Simplify that to give me 4x squared plus 12x plus 9 equals 0. Then I'm taking this, multiplying it to every term, and then I'll multiply this one to every term. So in red I will get 4x to the third plus 12x squared plus 9x. In blue I'll get negative 16x squared minus 48x minus 36 equals 0. Combine like terms. The degree equals 3. That is my biggest exponent, and I did have 3 answers here, 3 zeros. 1, 2, and since multiplicity of 2, it's going to be another one, so 3. Next example. So, split up again. X squared equals 0. Take the square root, we'd say that x equals plus or minus 0, radical 0, which is still 0. X equals 0. But we know that since we had 2 of them to start out, I'm going to have a multiplicity of 2. Next one. X squared minus 2 equals 0. Add the 2 over. Take the square root to get x equals plus or minus radical 2. So I have x equals a positive radical 2 and x equals a negative radical 2. And the last one. 3x minus 5 equals 0. Add the 5. Divide. So you have 1, 2, 3, 4, and 5 solutions. And we can see we had 2, 3, 4, 5. We would have had 5, a degree of 5, which also means 5 zeros. We're going to multiply these to find it in standard form. If I do the binomial to the binomial first, I will get 3x cubed minus 5x squared minus 6x plus 10. Then multiply by x squared to all of them. 3x to the 5th minus 5x to the 4th minus 6x cubed plus 10x squared equals 0. So once again, degree of 5, 1, 2, 3, 4, 5. And how I counted up here, 2, 4, and the 1 here would be 5. So the reason that was important is because in example 5 it says, find the degree and number of roots or zeros without multiplying. Don't do any work, just by looking at it you should know. So we count. This first one here has a degree of 3. This next one has a degree of just a 1. And the last one has a degree of 10. So 3 plus 1 plus 10 equals 14. So my degree is 14. Therefore my number of roots or zeros is also 14.